Hello guys. So let's start today's discussion on the research paper called Determining the Nutrition Value and Recipe of Food from Images Using Convolution Neural Network. How's your Josh guys? Today is the very best project that I have researched in my college time called Determining the Nutrition Value and Recipe of Food. So basically in this project we will determine the nutrition of a food from images using a convolution neural network. So this is the best project. If you want to do it in your college time, you can do it. You will get a very good understanding about deep learning and computer vision related tasks. So my name is Naran Singh Dangi, as you already know that, and we have a four members like in my team like Soumya and Vishal and Amit Kumar Verma. We have four members to do this project in my college time. So let's start the discussion like how we have done and how we have think about this project and how to do this project. As a, also I will provide a code for this to do image classification and all of these things, like how I have done. I will provide all of these things. So let's start the today discussion. So that's done. So the abstract, or basically we can say like the motivation of this project. So basically nowadays we are seeing that we will eat anything and we are not able to understand like what we are eating. So that's the problem. To solve this problem, I have created this project. So by providing the image of a food, we were able to understand, or we will able to know that like what are the ingredients are available in this food. So what we have to eat it, like what are good for that in our health. So firstly we have started initially by thinking like that, but after basically we have created in 2022 this project. But after 2023 we know that the ChatGPT will come, so we have integrated this our model to a LLM model like ChatGPT. So this will also able to give our instruction according to the food that we have built it. Firstly we have to detect the image, like what are the ingredients are available in the image, and after that we will provide this image to the name of that to the LLM model, and LLM model will understand like what is what we have to eat and what are the ingredients. All of this information that ChatGPT will give you by only providing the image of a food. So that's how this will work. So let's start. So like we have applied all of this in the introduction. I've already covered. So we have also created a app, Android app, or we can say iPhone app, that can detect. Firstly, we have to take an image of a food. Like this is a real-time image detection, or basically to detect the food ingredients, like what the ingredients are available. You don't have to rely on the internet. This will be a offline mode app. So basically what we have done, firstly we have created a TensorFlow light model, and then TensorFlow light model integrated inside a front end directly. We don't have created API. We can also create our API in first API. I've also already created it, but for that project I have don't use this API directly. Embed this API like our TensorFlow model, TF light model, inside our front end. So directly we don't rely on the internet. Directly this will call to this TF light model, and TF light model will understand like what is the image and classify the image, and according to the classify image we have a nutrition data set also. So let's understand what is this. So basically this is our image data set. We have of different 30 categories. Firstly we have classify only 30 categories, then later on we will extend to 200 and 1000 categories, also different images. And this is our nutrition data set. So inside a nutrition data set, basically we have image and cuisine.csv file. So inside a cuisine.csv file we have ingredients related to this food name. So basically load this bun and buns b. So basically this is the image looks like. So this we have a name of that recipe, like how this image can like name of that food, and this is the image, and this is the description. So basically what we have to do, firstly we have to classify this image using a CNN or deep learning model, and then we, according to this name, we have to suggest these ingredients are available in this food. That's how this will work. That's it. only for this project. And so let's start how to build this project. So initial food classification approach, basically we have some different model which are not good at that time, and now we have shifted toward deep learning, and so this will be work very well. So firstly we have a 3500 images only, and we will get a 62% of accuracy with 85 food items only. But now by using a C like deep learning, we will get a good accuracy, approx 90 to 98% we will get. If we have a less number of categories like 30 categories, then we will get a good accuracy. If we increase that number of classes, we will get some different like 90% of accuracy. That's how in summary. So this the process that we have taken it. So firstly what we have a food image, and then basically this image will be passed to our image pre-processing model, and this model will be like trained to train the CNN classifier. We have trained this model on our custom dataset, and then we have to test it dataset, and then after testing a dataset, compare the system with the other feature based on the model, and then further analysis to determine ingredients of food. So this is all done, and like this is all the also known as the classification model. And here after we have classifying this image, like if this is a potato or like something rice image, then rice, then we have to suggest like in rice we have this type of ingredient at that time. But now we have LLM model, so firstly we have to detect it like this is what is this image, and then after that we have to pass this image to our LLM models, and then LLM model will suggest it, the ingredient and all of this information regarding this food. So first also we have collected 5,000 images with 50 categories, so that means 100 images of every categories we have collected it, and train it on like 100 training clips, or we can say 100 approx, with 10 test clips. And like 10 test clip means like 10% of our data set as our testing data set we have taken it. Now coming to the average pooling layer. So average pooling layer, I think this will I will explain in the code. That's here you can understand it very clearly. And this is the model architecture that's look like this, and all of these things. So let's come after this. Firstly we have to I will explain the code, how to create this code. So firstly we have to import some library like NumPy, Panda and Matplotlib, and TensorFlow is the best library to do our like deep learning related task. So now understanding like how to create it. So firstly we have to import this dataset from the directory. We have download and dump this dataset in our drive folder. So here we have to import it all this dataset, right? Using our TensorFlow case library we can import it, and after that basically dataset.class name. So here we can get all the class names that we have. Firstly we have trained this dataset only like model on the 15 different categories. Later on we have increased this number of classes like 30 to like 90 or 100 or 1000 classes we can increase. So we have a length of dataset is equal to 42. 42 means basically 42 into a batch size of 32. This is a, when we upload this dataset, there is a batch size of basically we can say input, or we can say what I say a normal, or we can say a default, yeah, default value of our batch size is 32. So that's why it 42 into 32 like different number of images we have. So in each like batch we have a 32 different type, 32 number of different batches, and each batch has a 32 images, and in each batch we have a 32 images, and each image will have a like 256 into 256 comma across 3 pixels, and related to the class, like which class this will fall in. So and the after that we have taken as a firstly 35 batch we have taken as a testing training data set, and after that 7 batch size we have taken as a testing data set. Now coming to the model building, so here we don't have to do image pre-processing something like that, because this is simply a classification model, and only we have, if we have a best class like training data set or like classes of different already have, then we have to do not do have to any like do have to any pre-processing and something like that. Only we have to 10 test splits, and then after 10 test split we have to create a model. So now coming to the model creation. So firstly, we have to define the input size, input layer of our model. So the input layer basically is a input size, input shape we can say of our image. It will be a 256 cross 3 image size, and then we have a ReLU activation function, and after that we have taken the image, and then we have to apply convolution 2D layer, and here we have number of filters, like how many number of filters you have to convert it this image. So we have applied 32 firstly, and kernel size we have applied 3 cross 3, and activation is a ReLU. So I explain all of these things like related to deep learning, like CNN model in the deep learning playlist. You can check it out, like what is the meaning of convolution 2D, what is the number of filters, kernel size, and activation function, and everything I've explained it. So this is same, and so if we apply this, the number of if we pass this as a 256 cross 3 image, then we will get an output as a n minus f plus 1. N minus f plus 1 means number of features, like firstly n minus f number of filters plus 1. So 256 minus 3 plus 1, 254. So 254 output as a 254 cross 32 means 32 means basically number of filters. So number of filters, this is the output of this first layer, and after that we have applied max pooling 2D. So max pooling 2D will basically give a max feature of that image. So we will get a half, like 127 cross 32 image as output, and then again we have applied a convolution 2D layer as a 64 number of features, and again same thing we have applied. So that's how it will work, and after that we will get something like that. This here you can see that, and here we will get a 14 cross 64 output, and here we apply the flatten layer. So flatten layer basically convert a dense layer, and after that we can apply a dense layer like ANN model. Here firstly we have a CNN model, and after that we have a ANN model. Here we can see that, I think I yeah. So firstly we have an image, and then we have to convert it into number of different pixels, and after that pixel we have convert this into a flatten layer, and after this flatten layer we have converted into a dense layer, and then dense layer will be converted. Basically here is a CNN model, and after converting into flatten layer we have to apply a dense like, or we can say a NN model like artificial neural network, or we can say artificial neural nothing but our brain of neurons, which will looks like that. So that's how this will work. And output we have defined as a 15 number of classes and applied a activation function as a ReLU. I think you already knew that. If we have a output of 2, then we have applied a sigmoid activation function, but we have a greater than, if the number of output classes have number greater than number of 2, then we apply a softmax activation function as a output. Here we can see that our matrix is accuracy, and optimizer is Adam is applied. Optimizer is Adam. Or we can say like 90 to 98%, 99% cases we have applied Adam optimizer, because Adam optimizer is the best optimizer now in the market, and it will be a combination of all of this optimize. Like firstly we have a gradient descent, stochastic gradient descent, or basically mini batch SGD, and many gradient descent function we have, but Adam optimizer works very well because it has taken all of these combination of previous gradient descent, and the combination, like it is in the Adam optimizer we have a basically alpha known as a learning rate is basically we can say a variable it's a variable learning rate, and firstly it is very high, but after training some epochs it will slow down, because we know that after basically our gradient descent function looks like U curve, and firstly we have a error like this, but after basically we want some small number of small value of alpha, or basically alpha basically learning rate, so that our firstly we have to learn very fast, but after some number of epochs, or basically after reducing some error we have to minimize this alpha, so that our learning will be slow, so that our gradient function will not zigzag motion. That's why we have to apply it SGD, or we can say stock or momentum we have to apply it, and momentum is also applied in the error, so that our this function will works very well. and apply a matrix as accuracy and loss function as a sparse categorical cross entropy. So we will apply a categorical cross entropy. Our output is have a one hot encoding, but we don't have an output as a one hot encoding, so that's why we have to apply a sparse categorical cross entropy. And we have trained only a 5 number of epochs, and we will get accuracy like 86%. That's how. And after that, on testing, we will get 86% of accuracy, like, approx. And this is for predicted function, and here we can see that this is actual class and predicted is same with a confidence of 80%, and here actual and predicted is same and with a confidence of 90%, 99, 99. Here you can see that with a 84%. That's how it will work. For the confidence, basically we have a function like np.max. Here you can pass it out. That is, yeah, model. Firstly we have to model dot predict it, and this will give a prediction in a softmax activation function. So according to the softmax activation function, we have to apply like confidence. So basically max prediction we can get it, and here we can getting np.argmax, like which argument have a, so which this will give a predicted class, which class we have fallen in this category. That's how this will work, and this is very easy as of now. So firstly, what we have to do in this project, firstly detect the image, like what is the image, and after detecting the image, then we have to find the ingredient, like this ingredient, like with this is basically this is a one to one matching, and if this has a part like potato disease, then potato image, then we have to like match this like in potato we have a like this type of different ingredients. That's how this will work. So for this project, basically firstly we have created all of these things, and this is our nutrition data set looks like, and this is the our output of the test model, and this is the running app demo. Here you can see that we have created also a app. So by providing, this is the app link also, you can get it, but now I have deleted maybe due to I have not have access to that app. So here you can get it, like if you provide this image, then firstly this will give the name of that image, and then like what is the ingredient, all of this thing you can get it out. That's how this will work, and that's it for today, guys. And also, like in future we are planning to firstly train a YOLO vision model. So what in YOLO, basically firstly this is YOLO is very good model. In YOLO we don't have to create a model, only we have to train this model in our custom data set. So firstly for this training we have to create a custom data set. So in dataset, basically this will also provide like label to this image, like where this is present, like this will create a boundary box also. Using a YOLO we can create a boundary box like where this cuisines, like, or we can say food is present inside our image, and like how many confidence and all of these things we can get it out. And after that, basically detecting this image, we can pass it to this name to the LLM model, and LLM model basically will give output to our like what is the ingredient, all of this related to food we can get it out. That's it for today, guys. Let's meet in the next lecture. Thank you, guys. Jai Hind, Jai Bharat. How the Joes? Good sir. Hi sir. Let's subscribe my channel, guys.